So yesterday we have learned about a lot of theory, actually, like star schema, snowflake schema, normalization. There are a lot of things that we learned actually. I will just do a quick recap of what we learned yesterday, and then so that it will be clear, it will just fit in your mind, and then we'll continue with the other things. So first thing we have learned about is the database. Okay, a database is a collection of tables, views, stored procedures, okay, all of this. But in the case of big data, we will not we will not be able to deal with stored procedures, functions, and all. We'll be dealing with only tables and views. Okay, so why I'm stressing this again and again, so that you will have this back of your mind. We'll also see practically how things work. And in the case of big data, okay, we'll be storing the data in the files. Even though we create tables, we will be storing the data in files. Now, as I told you yesterday, we are going to normalize the tables, means we'll be applying normalization, like splitting the tables to the biggest extent possible in the case of OLTP databases. But when it comes to OLAP databases, we'll do the denormalization. Normalized tables will be done in OLTP, denormalization will be done in the OLAP databases. Guys, you are able to hear me, right? No issues, right?
Yeah, Vinod.
Yeah. Now, apart from that, we also discussed about a little bit about the dimension tables. Okay, we also discussed about the fact tables. Okay, fact tables will store, okay, primary key columns of dimension tables, primary key columns of dimension tables, and then the quantitative measures. And dimension tables will, the fact table data will be controlled by the dimension tables. Now, when it comes to data modeling, we have two types of data modeling. Okay, two types of data modeling, that is star schema and snowflake schema. So when do we go for a star schema? When do we go for a snowflake schema? Okay, if I am working with some people who is having good idea about DB, then we can go for either of them, star schema or snowflake schema. But if I am working with some people who don't have a good knowledge of databases, okay, then we'll go for a star schema only. Okay, why this is the case? Because if we go for star schema, if you now work with any of the, okay, data analysis team members, okay, if they use Tableau, ClickView, or Power BI, if they drag and drop the fact table will, it will fetch related tables. It will fetch related tables directly. Okay, and it will be simple for them, and it will be simple. Okay, but on the flip side, if people are good at databases, they will write SQL queries and create dashboards. So that's why you can create any of them, if at all, if you are working with the other people. Okay, I will just show two schemas that I recently, like a few days before that I worked. If you could look at this, this is the hiring related information, wherein I have one fact table and I have connection to all the dimension tables directly. I have connection to recruiter. In the case of hiring data, you will be hiring the candidates. I'll be, so there will be a recruiter, there will be a hiring manager, there will be phases, states, which location you are hiring, which organization you are hiring. Okay, in one particular organization, you will have a lot of sub organizations. That's why we'll have this. and he will release the offer and when he is going to submit the documents and all those stuff. So every table will be connected directly to the fact table. Okay. On the flip side, this is another data modeling wherein you have a fact table, you have another fact table, and if you could see, there are dimension tables connected to this fact table, and there are dimensions which are connecting between the dimensions. This is the snowflake schema, wherein a fact table may not have a direct relationship with all the dimension tables. So this this is a clear case of a snowflake schema. Okay, we may try to make it a star schema, there is no issue, but leaving this way will also help sometimes, so that's why it is left as is. Okay, this I wanted to show. This is the star schema where is the center fact table and all dimension tables connecting to it. Okay, there is a bridge table over here. What is a bridge table? So this particular data model may connect to another data model. So we may create a bridge table. Okay, here this particular bridge will connect to this particular data model only. The other one that I have shown. So that's why this bridge table was created. Okay, just that you are bridging a table which defines the relationships between two data models. Like that, you are going to do the data modeling in the case of any case, even in the modern data platform also, you will have data warehouse designs. Only thing is, in the case of like modern data warehouse, it won't support primary keys and foreign keys. So this you have to keep in mind. Okay, this is what we discussed yesterday, and still, if anybody not clear about this, let me know. I will try to explain, and then I will move ahead with the other topics in the sequence.
So we know the data modeling, do we need to have a idea completely to move forward here?
So data modeling is not mandatory. It is the job of uh,
Advantage.
architect. Yes, it is an advantage, additional advantage for everyone, but it is the job of a data architect. But it doesn't matter. People question you regarding the data model, like what is star schema, what is snowflake schema. Whenever you talk about a ETL developer, they will talk
Yeah,
that, right?
slowly
So
changing dimensions. You need to have a surrogate key ID. So what
yes,
surrogate key has to do in this modeling? Any
we need
clue?
to create a natural key. Okay, we need to create a natural key. So what is the natural key? From the source itself, from the source that we are trying to load the data, we will use the key. We will not generate any key.
Okay.
Okay, we can generate, but the problem is, okay, what we have done, Databricks has created something like we can generate a key, but that won't work if at all. If you are, let's say I'm trying to load into one table, then I'm trying to do it with parallelly, right? I'm trying to do into 10, there are hundreds of tables getting loaded. We're trying to load. So whenever it is generating the ID column for audit table, it is not able to do that because there is a duplicate ID already. So that's how it is not completely supporting it. It won't support also. There is no way that it will support. So we have to somehow make a key. We'll see how we'll do in the project. Okay,
If we
right
have
now.
one business case, like a small example, let us
Mm.
say if there is a new, so there is an organization, if there is a new application coming in,
Mm-hmm.
and they need the daily transactions are going on to the database, and
Okay.
uh, and at the same time we need to utilize the warehouse. So there are 100 tables in that, and there is a requirement of a reporting also
Mm-hmm.
for that table. Okay,
Mm-hmm.
we have selected 20 tables are like that,
Okay.
and then we go for a modeling or reporting. So
Okay.
at the step by step, how many steps are involved from the creation of a modeling to the reporting with those 100 kind of tables when the database is and then the application is set up?
So
that
if you are
workflow.
if you are talking in the application side designing database, or you are talking about a data warehouse designing
Data
data
warehouse,
warehouse?
not
Okay,
data warehouse.
I will talk about this. I will talk about this, Ravi. So right now, if I talk, it will be overwhelming for the other people. I
Okay,
will
okay,
talk about ETL flow. Okay, let me explain the architecture so
okay,
that
okay.
everyone will have idea. Okay, so in the traditional ETL, okay, extraction, ETL, right? So extraction of data, transformation, and load. Okay, now let's say there are many source systems. Let's say, for example, if you are working for a healthcare, okay, now you have a lot of source system, not one source system. Okay, let's say we'll consider this as a sources, different kinds of sources. Now this is the cloud warehouse. This is the cloud warehouse. Okay, fine. Now I need to bring this particular source data. Okay, and then I will move ahead with the next steps. So in any kind of a okay, in any kind of a database, in any kind of a data warehouse design, in a cloud warehouse or in an on-premise warehouse, first we'll analyze the number of source systems. There can be one, there can be n number of source systems. Okay. Now, what we'll do, we'll try to create different stages in the case of cloud warehouse. Okay. For each source, for each table, let's say I'm working on a finance database. Okay, finance source, and I have like 100 tables here. I'm working on HR tables. I have 100 tables here. Okay. Now, in any database, we'll have different stages like staging, ODS, and data mart. Okay. Now, from this particular source to the staging, you will have a one-to-one map. Each source for each table, you will have a file or a table. You will create like this. Staging will always be truncate and load, means you will fetch the source table and load it into staging table. Every day you will do a truncate and load. Okay. Hello. You guys are able to hear me, right?
Yes, yes.
Yeah.
Yes,
Yes, we know.
Yeah.
So
So
truncate, and here we truncate daily in the sense the same table capacity will be there here also,
yes, same table capacity will be there. We'll talk about
but
it
it will
actually.
be truncated daily.
It will be truncated. We'll be able to achieve that. That's when it became a hit. Otherwise, we'd have not went to the cloud warehouse. So staging means truncate means, guys, some of you who don't have a SQL background, truncate means you are going to remove all the data and load. Okay. Now, when it comes to ODS, for each table again, you may do some kind of transformation, little bit like removal of nulls, duplicates, because you may extract the data multiple times in a day. Okay, and while doing that, you may see some kind of nulls or duplicates. You clean up the data, little bit of transformation you do, and again you may do small modeling also. Okay, or you may keep as is based on your organization standards. You may keep. Okay, now when it comes to data mart, you definitely follow this facts and dimensions. Okay, if you are not doing these facts and dimensions in the data mart, you can directly read it from the ODS itself. But staging, you should be very careful since it is truncate and load. In the case of ODS, you may maintain history of the data. You will not truncate the data. You will always do insert update. Okay, in the data mart, again you will have the history of data, but with a controlled way, in a very controlled way. If you have 10,000 tables, you may not have a 10,000 tables in the data mart. You may end up having 1,000 tables only. Okay, because that is modeled, that is directly usable. Okay, it is, I would say, completely curated data. Completely curated data, we call in the modern terms. Okay, people also call bronze layer, silver layer, gold layer. And if you talk about, you still talk about, if you go for interview and you still talk about staging ODS and data mart, they don't agree that you worked in a modern data platform. You should say, I worked in a bronze, silver, or gold layer, or you can say landing, and you have curated, or you can say, and then refined, and then curated. Like this, you have to talk. You have to use modern terminologies. Okay, you cannot use the traditional terminologies here. From here, you can, so Power BI is capable of connecting to any of these databases. Let's say if I put a Power BI or any reporting tool, it can connect from bronze, it can connect from, sorry, it can connect from bronze, it can connect from silver, it can connect from gold, but in any environment, in any office, they will let you connect to gold or a silver data because you have done some kind of transformation which is clean, you got the history, and you will be able to proceed further. Okay, these are, here you will do the data modeling. Data modeling come to picture in this particular case. Whatever I talked about, you will definitely do. So this was designed for a, okay, this was definitely designed for a cloud warehouse. Okay, they use Synapse notebooks. Okay, they use cloud warehouse. There is, they are not using any on-prem. If you could look at, okay, surrogate keys and all. Okay, this submission ID is coming from source, person ID is coming from source. I have not added any new key. IDs are all coming from source. If at all, if it is not making a unique key, I will make a combination of columns and then create a unique key. 4 or 5 columns will combine and make a unique key. Okay, no need, no way that we can generate a key. So that's a catch. That's okay. That's how we have to live with it. Some people generate a hash key. I will show that while doing the project. Hash key and do that. We'll understand while doing the project. Because if I say truncate, if I say absurd, if I, all these things, I need to clear first the basics for the people and then I will talk. Then it will be easy. Is that okay, Ravi? You got the idea now?
Yeah, excellent.
Yeah.
So, yes.
Yes, if you have further questions, you can ask.
No, not at this moment.
Okay, fine. So before starting the Spark SQL, I have few things that I need to talk about. Okay. You all have to remember in the case of big data, we have 4 things. I'll put this thing. Okay. Storage, storage of data, compute, data, and metadata. So why I have to talk about this is, so if I take this SQL server, okay, this is a SQL server, traditional SQL server. If I create a table anywhere, then let's say if I create a table, create table, let's say sample, ID int, okay, let's say I create this table. Now, in this particular case, okay, I don't worry about where the data is getting stored. Okay, how the data is getting stored. Okay, now when it goes to big data, okay, when it goes to big data, data will always be stored in the files, okay, and metadata will be stored in the user interface. User interface is Databricks. If I take here, if I create a table, let's say I will take a notebook, okay, there is something called as a catalog here, right? Now, if I open a notebook, let's say if I create a notebook, simple, I will talk about creating tables, everything in detail, but I'm just trying to explain. Create I'll do percentage SQL because it's a magic command. The notebook is of Python. I'm going to write a SQL. So I have to either select the SQL and then write the code. Create table. Okay, same sample and then ID integer. Okay, now here this particular sample, okay, will appear over here, and here also in the traditional database also will appear. Okay, that particular table will appear in the system database I have created in the master database. If I go here, I can see the table. There is no issue. I can see this table. Okay, but here also, okay, it will create. There is some sample or whatever. I will do 1, 2, 3, 4, 5, 6 because I would have created a hell lot of sample tables for the previous batches while explaining. So that's why. So whenever I create a table, it will create a folder. It will create a folder in a path. Okay, it will create a folder in a path percentage fs ls. I will explain what is this path, what we are going to do with this path. The default path for files is user hive warehouse. Okay, if I go here, I can find this sample 1, 2, 3, 4, 5, 6 folder. Okay, sample 1, 2, 3, 4, 5, 6 folder, and it will display over here. I'll show that. So in the case of big data, you should know both. Here, in the case of table, knowing the table name is fine, it's over. But in the case of big data, you need to have you need to know where the data is stored, which file format it is stored, and you need to know where the metadata is getting stored. So that's the difference in the case of big data. So in the user hive warehouse, I have created a lot of tables. That is fine. There is no issue. This is the sample 1, 2, 3, 4, 5, 6. This is the folder where the data is going to store. Data is going to store. But metadata is here. Means the table metadata, I didn't talk about metadata. It is data about data. Data about data means there is a table. Okay. What is the table name? What are the columns available in the table? Okay. And what is the data type of each column? Okay. Here in this example, the table name is sample 1, 2, 3, 4, 5, 6. One column is available and its name is ID and it is of integer type. So that will be stored over here. That will be stored over here. Okay, but the data will go into the file system. Data will go into the file system. There is no way in the traditional database you will be able to see where this particular table data is stored. Okay, there is a MDF, LDF files where you can say like this data can store over there, but you cannot pinpoint to the file where the data is getting stored. Okay, so that's how in the case of big data, data and metadata stored separately, but in the case of traditional database, they are closely coupled, means table manages everything. Table manages everything. So why I'm talking about this is, okay, in the case of Databricks or any big data, we can provide a location to the table. Okay, provide a location to the table where it should store the data. Where it should store the data. Okay, so this will help in two ways. Okay, two ways. That is, even if you delete the table, I can keep the data. I can keep the data. But in the traditional database, if you go and delete this particular table, let's say if you delete this, then it is gone. Table will be gone, data will be gone. But here you can control. Either you can provide full control to the table, or you can restrict the control to delete just from the catalog. Just this metadata will be gone, but table exists. Okay, those are managed and unmanaged tables. Those are managed and unmanaged tables. I will clearly show that, and then I will also this time for this batch will also do a working session wherein I will come up with the task in the class itself. You guys try to create things. I will once I explain the things, we will do that. Okay, so the data and metadata is separate in the case of big data. You must remember, anybody not able to understand, ask me about this. Data means the files where the data is getting stored. Metadata means structure of the table. Are you guys clear?
Yes, Vinod.
Okay.
Yeah.
So when it, yeah, somebody is trying to. Okay. So I also talked about storage and compute. Okay. Storage. See, in the case of traditional database, this particular SQL server manage the storage. Okay. Once you provide the folder name, it's over. Where that MDF, LDF files needs to be stored, it will take care of everything. But in the case of big data, every for every table, okay, for every table, you can manage the location. Okay, you can manage the location. It will not in the control of. You can control everything. So why I said another thing is why I said storage of data is different from compute of data. So whenever you take your machine, there is a limit on the number of like how much like disk I can add, how much CPU I can add, how much memory I can add, right? But in the case of big data, you can add up to like in the case of database, there is a limit like 400 computers to take care of your okay, to take care of your use case. You can go, there is no limit actually. Like you can request them to increase more, they will increase. There is no issue. But you should be showing that much bill, then only they will increase. And also, since you are using a file system, you can store, let's say if I have a Google Drive, if I purchase 1 TB, 100 TB, 1000 TB, and if I tell them give me unlimited, whatever I store, you can bill for them, they will give that. Okay? It can grow itself. But in the case of our machine, where I have 4 CPUs and there will be a limit on the size of this like disk, it can control the disk in the case of traditional system. In case of traditional, it can control the disk capacity. That's why cloud is very important. It can, it is, it can grow like it is elastic. What does elastic do? You can stretch it as much as you can, right? Like if not, it may come out like it may break, but elasticity, it is called as a elasticity in the case of cloud. Okay, that's why people use cloud. I don't want to, okay, bug people every damn day, every minute, every second. My database is getting increased. Can you please take a look? No, no need of all of those. Okay, it just manages by itself. That is the elasticity. You can increase number of CPUs. That's the elasticity. You can increase the size of your okay disk. That is the elasticity. It is elastic. Cloud is elastic, and that's the flexibility that it gives. Hope you guys are clear with this understanding. Okay, this may not, this may come handy in the case of real time also, data and metadata particularly, and also this term elasticity. Anyhow, let's talk about Spark SQL. Okay, Spark SQL is mainly kind of a traditional SQL only. People started adopting Spark only when SQL came into picture because people love SQL. Now, any database anywhere we have different kinds of like languages in the case of SQL, that is data definition language, okay, data manipulation language, okay, DDL, DML, DCL, it is a data control language, data retrieval language, okay, and then you have transaction control language. Okay, I will explain everything in detail. Okay, data definition languages. So you are creating the definitions in the data. What are those? Like create database, create a table, create views. Anything related to create is data definition language. Okay, create views. Alter also. Alter all of them, like alter table, alter view. Okay, adding a column, deleting a column. All these, okay, all these comes under data definition language. The database, create table, create view, alter database, alter not, you cannot alter table, alter views. These are the data definition languages. Okay, anything related to definition, anything related to create or a definition, altering the definition is the definition of the data definition language. What is data manipulation language? Okay, in this structure, like you have created a table. Now you are going to insert the data, delete the data. Okay, update the data. This is the data manipulation language. Row level operations. Row level operations is DML. Row level operations is DML. Insert, yes, you are going to alter something, you are going to add new rows or something. Okay, delete, you are going to remove some rows. Update, you are going to update the data. Anything that you are dealing, okay, at a row level in terms of inserting, updating, and deleting, that is the manipulation language. You are manipulating something. Okay, that is the data manipulation language. What is data control language? Data control language is granting permissions and revoking permissions. Okay, grant means for a particular table, for a particular view, for a particular database, you are going to grant some permissions. What kinds of permissions? Read permissions. Okay, read write permissions. These kinds of permissions you are going to grant. Okay, and also you can grant them, okay, DDL permissions also. Okay, DDLs means they may create tables, they may do alter the tables, all those stuff. There are different kinds of permissions that you are going to do in the data control language. What is data retrieval language? It is select statements. So we all supposed to be good at select statements. 90% of the times we use DRL, data retrieval language. Data retrieval language is very important for all of us. We'll deep dive into every topic. Data control, there is a notebook I will just walk through, but it's not very important because I think database admins have the control because they have to follow information security and everything before granting the permissions. Not everyone will have this ability to give the permissions. Just know that you can give access to someone and you can revoke access to someone. That is fine. Select statements is the thing that you are going to deep dive. We are going to deep dive definitely in the other topics. Now, what is a transaction control language over here? Transaction control language, if you take traditional databases, okay, whenever you write something, if you want to do, if you are inserted a data, if you take SQL, Oracle basically, then if you are trying to insert the data, once insertion of the data, you are going to commit or rollback. Commit means you are actually telling the database, whatever I have done is correct, please take it and then update the data. Rollback means, no, I have done something wrong. I don't want to, okay, proceed further. Can you restore it to the previous stage? Restore it to the previous stage. Okay. In the case of cloud, it is auto commit. Auto commit, if there is any failure, auto rollback. You don't have this thing in the cloud, But in the traditional databases, you can do this transaction control language. This is out of scope. All these are in the scope. Data definition language. Okay, create database, create table, create view, alter, data manipulation language, data control language, data retrieval language. These are important for us. These are important for us. Okay, we'll start with the data definition language today. Okay, for all of you, if at all, if you look at it, there is a notebook called Spark SQL tutorial. Okay, I have it everything defined over there. SQL DDL, SQL DML, DRL, DCL, everything is in different folders altogether. You can go and check and then practice all of this. I'll start with the DDL today. I'll start with DDL. Okay. Now, let me. Any questions over here, guys? I forgot to ask any questions. DDL, DML, DCL, and DRL. Anyhow, we have not started, but just a overview and differentiating which statement is called as a definition, manipulation, control, and retrieval.
So, the data sorting or ordering will come into manipulation
Data
or
sorting, ordering will come into DRL because
DRL. Okay.
yes, you can load it before doing it is all DRL. You can manufacture the data and then loading. Okay, that is DML. Loading is DML, but sorting and everything comes into DRL itself.
Okay, select in the order. Okay.
Yes. Now, there are a hell lot of things that we need to learn in the case whenever we try to choose the Databricks, but it'll be thrilling for all of you. For teaching also it will be thrilling. For learning also it will be thrilling. Now, when I say create database, okay, create database, what does it do? What does it do? It will create a folder. It will create a metadata that goes into catalog, okay, and it will also create a folder. It will also create a folder. Okay, which folder it will create? Okay, which folder it will create? So actually will be Databricks will have some kind of file system called Databricks file system, DBFS. It is Databricks file system. Same, don't consider it as something different. If you take your particular machine, C drive, D drive, whatever drives, and then folder, inside a folder there is another folder, this kind of thing only, there will be a Databricks file system. Databricks file system, they use Unix. Okay, Ubuntu is the machine, but we don't have to worry about it. It's okay. Databricks file system it will use. Okay, it is nothing but a Hadoop distributed file system, or you can call it as a file explorer, like the folder structure in your local machine. Now, in the Databricks file system, there is a default location. Okay, default location that is called as a user slash hive slash warehouse. If you create a database in the warehouse, it will create another folder, like it will go to user hive warehouse. In that you can actually create, let's say I want to create a database training. Okay, it will create a training folder inside. Okay, now as part of learning, all of us should know few commands in the case of Unix. Okay, if you want to know, you have to remember this at any cost. User hive warehouse is mandatory for any data engineer to remember. Okay, even in the real time also this comes into picture. Everywhere it comes into picture. User hive warehouse, you should remember that is mandatory. Okay. Now, if at all if I want to know this particular folder, then you have to you can write these comments: percentage file system list and then type user hive warehouse. Then it will display the folders inside this warehouse. Okay, there are, you can create any kind of a folder. There is no issue. There is not, it is not mandatory that you have to, but if you just say create database name, let's say training, then it will go into this folder. That's what I'm trying to say. You can create you can create any folder. You can create any folder and give the folder path to create the database in that folder path. But by default, it will create here. This is the default location. Okay, default it will store here. So create database, it will go into this particular location. Let's see that. We'll go slow here, actually a little bit. Once you understand how this folder things work, it will be easy. We open it here, create database. Okay, let me create a database. I'll just create database. So I can try directly write in SQL language because my notebook is in SQL language. I don't need to do a percentage SQL. Okay, just remember that. Database training. Okay, let me create this. Every day before the class, I will remove and recreate the cluster. Hope you guys are doing the same thing. Okay, it created. It took 2.27 seconds. It executed 2604. It created. Okay, it created a database. If you go to catalog, apart from default, there is a training database. There is a training database. Okay. Now, when you stop the cluster, since you are using a community edition, this database metadata will be gone. Okay. When I stop the cluster, okay, metadata will be gone. This won't appear here. Why? Because they are giving it for free. If n number of people in the world try to create n number of databases, n number of objects, it is difficult for them to manage this particular space. That's why they will drop this metadata. But folder remains. If I try to create another time, same thing, then it will throw an error. Then it will throw an error. The folder will be existing in this. Okay, schema already exists. That is okay. But even the folder exists. That is in the user hive warehouse. If I go, there will be a training folder. There will be a training folder. So what we are supposed to do in that particular case, I will tell you. User hive warehouse. I have created a training. T will be in the end. So a lot of them. I have created. Training.db. If it is a DB, it will be training.db. If it is normal, it will be, if it is a table, it will be just the folder name. If it is a DB, it will be training.db. This is where your objects will appear. Now, if you, so the problem will appear whenever you restart the cluster, create a new cluster, then you have to use another command. What is that another command? Percentage fs rm hyphen r. Then you provide its full path, copy this path. Whenever it throws an error, it will show the path. You can copy the whole path, this path. Okay, you can do this, there is no issue. Okay, and here I'll put and execute, it will remove the folder. So if you could see, I have created a database, but I have dropped the folder. I dropped the folder. It won't appear if I try to check again. It will not be there. It will not be there. Okay, this is how you operate with the data and metadata. Okay, what is the thing? Whenever you stop the cluster, the metadata will be gone and then you have to recreate them. You have to recreate them. Okay, let me, okay, I will just drop it and then recreate. If I recreate, it will create the folder again. It will recreate the folder again. Fine. Now, Always a good practice whenever you are creating anything, try to use create if not exist. Create if not exist database name training. Okay, because in the production environment, if somebody has already created, you are working, your friend is working, okay, and then there will be issues, then they will make noise. So to avoid that, use this keyword create if not exist. Okay, create database if not exist. Okay, even for the table, it's the same case, even for everything. Now it won't throw error. Okay, why? Because I'm saying if not exist, then only create. If I remove that statement, then it will throw error. Okay, create if not exist. Try to do this, then it won't throw error, and it will be it is standard practice, not good practice. In the case of cloud, you try to do this. Now, even while dropping means you are going to delete everything. While dropping the database, if you drop also, let's say training, let's drop it first and then try to drop it again. Then it will throw an error because it does not exist. Okay, drop database if exists. Try to remember this. Drop database if exists, it will drop. If exists, otherwise it won't drop. So this is the standard way. Okay, not the good practice. It's the standard way. Two commands you guys have to remember. Percentage FSLS user hive warehouse. Percentage FS RM minus R means you are forcefully removing this particular folder from that location. So these commands is really, really important. I'm going to put it in the chat. Where is the chat? I think I'm not able to. Can somebody ping me? Let's see. Yeah, I can put it in the chat. It will be there in the notebooks. There is no issue. But you try to remember this. You try to remember this. Okay, fine. Okay, there is something. Fine. Now, create database. What it will happen whenever you create a database, it will create a folder. Okay. And if you drop the database, it will remove the folder. Okay. Now, in the case of database, if I, let's say, if I just create a table, for example, okay, default, whenever you try to create a table, default, it will go to actually default location only. Default location only it will go. Okay. Now, since it's already there, I will try to clean up everything for the next class so that I don't face any issues. So whenever I try to create a table, default it will go to this particular location, that is the default database. Okay, table 123 came here. But if I want to create in the same, like in the database that I am creating, then I need to mention database name dot table name. Database name dot table name. Training dot table. Then it will create in the particular location. The catalog, if you go and check in the training also, the table will appear. The table will appear. So what does the table will now in the backend? What will the table do? Like what will happen inside this particular training.db? Okay, and press enter percentage FSLS. There will be another folder. There will be another folder called table 123. So database. Whenever you create a database one folder, table another folder, table another folder. So now only when you insert the data, then files will be created. We'll just check that also. We'll just check that right now. Guys, you are able to follow me? Any questions anybody having? Am I clear? Let's talk about create table and create database. Any questions anybody having? Hello?
Yeah, Vinod.
when we do it hands-on, I think that is when
Yes, you have to do
it will
hands-on.
be more
So once these notebooks
clear.
that I was
Yeah,
doing,
correct.
it got everything,
Hmm.
Wish, right? So you have to. That's why. See,
Yes, yes,
these are new topics, right? So you need both
correct.
theoretical knowledge and practical knowledge. So that's why I told in the first class itself, 1 hour of Vinod will be 3 hours of you because you're going to listening mode
Yeah,
in the class, and in your leisure time or whenever you get time, you will be practicing. You must be practicing. Okay, what I am going to
yes.
do after explaining everything, I will try to keep a small exercise after doing this whole Spark SQL. Right, I will explain everything because if I do the
Hmm.
working session every day, then it won't work out for you, for me, right?
Correct, correct.
So I will do in the end. I will try to create database. I may give scripts, but you can try to execute and see. In the class itself, we'll do that. Like after at the end of this Spark SQL uh, course, like this module. Okay, but uh, everything is given in the notebooks. A lot of
Yes,
things
yes.
is given. I would request you guys to practice. Then only it will be easy.
Thank you.
Yeah. So now, if I will also see if I insert the data, what will happen? Just I want to insert into table. Still, I'm not covering any DML things, but I'm inserting into table. Training dot table 1, 2, 3. So now intelligence is working, which is very good thing. Here you can insert the data 1 comma. Let's say winner. Fine. If you insert the data, if you could see here, there is this particular thing. Now you copy this. You don't need to do this every damn time, but this is also important. Okay. So once you check, if you could see over here, there is something called as a delta log file. Okay. There will be data also. Now if I yeah, I missed this values. Okay, just throwing it. Okay, one row inserted. That is fine. Now if I go here, then you will see there is something called as a part files. This is the partitions. It's a Parquet file. Okay. So this is where actual data will be available. This is where actual data will be available. Now you cannot read this Parquet file. Okay. For reading, if you want to read this particular file, actually, you can use percentage fs head. Okay, and you can do this. It will try to read the file and then display the data. The data inside a Parquet file will be in a compressed format. Okay, so you'll not be able to read. How to read? I will tell you. How to read, and I will tell you. We are not started with. I'm just in the detail itself, but I wanted to show this whole flow so that you have an idea. Okay, so database folder, table folder, data files. So you must be remembering this. Okay. Now the database, I told you default location is user high warehouse, but you can provide the path. Whenever I want to create a database, okay, I want to create a training one database, I can give my own path. You can always use user. Okay, inside user you can give anything it will create. You can give anything it will create. Okay, there is a user, there is a temp. These are the default ones. Inside that you can do whatever you want. Okay, now I want to create WH folder. In that I want to create training. Yes, you can do this. You can give this location. It will create database in that particular location. How I have to check? Percentage FSLS, percentage file system, list, and then go here. And then go here. Okay, in the list, I have so many things that was already created. That is fine. So, but I have all of this. Okay, I don't want to start with the tables right now. I'll start with the tables on Monday. Saturday and Sunday, I don't take classes. Okay, I need to prepare. I need to spend time with families. So I don't take classes. So Monday to Friday. So tomorrow and day after, kindly try to practice. Monday we'll start with the table creation. We'll understand. I want to create a table and load data into CSV files. I want to create a table and load data into JSON files. I want to create a table and load data into any format, XML. I want to create a table and load data into Delta, Parquet. So one more thing is, in the case of big data, there are few formats which are very important. Parquet, let's say Parquet, Avro, ORC, Delta. These things I will be covering. A separate class will be there. Big data file systems. If you want to learn before that, there is my YouTube video in the course content that I shared. You can watch that. But I will be covering 1 hour class. I will be covering while I start the big data. Okay, right now you think about it is another file system. Another file system. Okay, I'll be covering all of this. For Delta, we'll have, apart from these three will be covered in a class, we'll cover Delta also. Delta will take 2 to 3 classes to understand. Actually, I'll be covering this. Right now, just bear with me because the flow should be SQL only. Then only it will be helpful. We'll cover that. Any questions, guys, in the case of today's class? Main thing that you have to remember: database folder, table folder, data file, and then user Hive warehouse. Definitely, when I was trying to learn, I was in the same page as you. But don't worry, you will grab it if you practice. You will be able to follow easily. Try to put this in hands-on so that it'll be in your back of your mind. Otherwise, it'll be just like you will feel really good whenever somebody is teaching. But unless you do hands-on, it won't be helpful. Okay, tables, it needs a lot of time. I have to take a deep dive, so I'll cover from Monday. Today I'm done. Any questions? If anybody have, asked me. Otherwise, we can wind up for today.
No, Vinod, I think we got enough task to work on over the weekend for the practice of those
Yes.
tables and all those things.
Yeah. Fine. You will be. I have already shared the Google Drive with all of you. Please go through that and then practice. The notebook name is Spark SQL. Well, notebook name is Spark SQL. You can just Spark SQL tutorial. You can just use. Okay, guys. Thanks for the day. Have a nice day and have a nice weekend as well. We'll meet again on Monday. Bye for now.
Thank you, Vinod.
Thank you.